This is the second and last video from chapter 10, section 5, and it is on circumscribed angles. And those angles are ones that have sides that are tangent to the circle. So we'd be talking about angle D, and it's one side AD runs and touches the circle at one point, and same thing with BD, runs and touches the circle at one point. I'm going to be giving you different types of angles, and in short, just memorize the steps that I give you, and you'll be able to do it. So for this given example, if I want to find what ADB's measure is, all I need to know is what is the central angle ACB's measure and say 180 minus that angle. What you can also do is if I give you the central angle, if I give you this other angle and you want to find the central angle, you would just say 180 minus that other angle because both the central angle and the circumscribed angle have to add up to 180. So in example 1, it follows right along with the definition that's at the top. I want to know what ADB is, so I know angle ADB, and excuse my lack of symbols, is going to be equal to 180 minus 135, and then that is going to equal 45 degrees. I do need to see this work. Many of you have stopped showing me work. I need to see it in order to give you credit. I'm going to skip number 2 and go down to number 3. Same idea as up above. If I want to figure out what angle X is worth, or KNL, I can just say that angle KNL is going to be equal to 180 minus 120, which will then equal 60 degrees. Now, the reason I skipped number 2, this just switched it, but this example is I do not give you EGF as the central angle. I only gave you angle H, which is 30 degrees, and an outer angle J that is X, and I want to find X. So there's a couple of steps that you need to follow in order to figure it out, and then I'll highlight at the end the main step that you need to focus on if you are given a diagram such as number 2. So I want to know what EJF the angle is equal to. And I know that from our other lessons with inscribed angles in 10.4, this inscribed angle is equal to half the measure of arc EF. So it's equal to 1/2 the measure of arc. Let's do the actual symbols. 1/2 the measure of arc. Why is it not typing? Hello? Oh, EF. And let's put that we're talking about the measure of that arc. Okay. Oops, too many things written in there. And M stands for the measure. Now, I also don't have the measure of arc EF, so I want to keep trying to figure out different ways I can start to solve it. So I still know that the angle EJF is going to be equal to 1/2 the measure of EGF. That's also one of the common things that you can assume. So let's just make sure I put in the correct symbols for this. So 1/2 the measure of, hold on, let's do symbols. 1/2 the measure of EGF. Okay, so I hope you're starting to follow that this inscribed angle is also half of the central angle. Then I can keep simplifying because I'm like, wait, I know how to figure out with the central angle how to find that measure using this circumscribed angle theorem. So I then can say that EJF is really equal to 1/2 of this formula here, or 180, oops, let's not retype in there, 180 minus EHF. Remember, they're interchangeable using the central angle or not because they both add up to 180 anyways. So I can say, let's copy this here just so I can be lazy. Okay. This is really the only step you need to know in order to figure out an angle that is inscribed within a triangle, within a circle, and you also have a circumscribed triangle. So you'd be taking the inner angle and you're going to cut in half 180 minus the outer circumscribed angle. So if we quickly do that math, we have EJF is going to be equal to 1/2 of 180 minus 30, which is then going to equal 1/2 of 150, which is then going to equal 75 degrees. So if you can just remember this highlighted portion, remember inscribed angles, it's going to equal 1/2 of 180 minus whatever the outside circumscribed angle is. There's not going to be too many examples like that, but just understanding the yellow step and me seeing that work is good enough.